Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Right, let's have a look at the inequalities that have fractions in them. So the first one there, x minus 5 over x minus 1 is greater than minus 3. So how do we solve this inequality? Okay, well, there's a little bit of theory here you have to mind, and that's as follows. If I have, for example, x, if I'm trying to solve 2x being greater than 6, okay? That's straightforward enough. I would get x being greater than 3. If I had minus 3x being greater than 6, for example, well, I have to change the signs all the way across because it's in negative x values, and that changes the direction of the inequality. Okay, and we had that in some earlier examples. So we would get x being less than minus 2. So what started off as a greater than sign in the solution ended up being less than. Okay, why am I telling you that? Well, this number here on the left, whatever number that ends up being, okay, could be positive or negative. Okay, if it ends up being an overall negative number, wouldn't it change the direction of the inequality when I go to solve it? Whereas if it ended up being a positive number, it would leave the inequality sign alone. Okay, so there's this unknown in inequalities as to whether the left-hand side, the x's are positive or negative, because x is a variable that can take on any solution. So, for example, I'm trying to think of a number x could be that would make that negative. Does it work with 10? We would have 10 minus 5 over 10 minus 1. No, won't work. Well, I can't think of one off the top of my head, but I'm sure there's a value there where x could take on a negative number. So this unknown is not ideal, so we need to have a work around it, right? The workaround we have is that when you square a number, it's always positive. Okay, think of the number 3 squared, that's 9. Think of the number minus 3 squared, that is also 9. Okay, so it doesn't matter if the original number was positive or negative. When you square it, it becomes positive, because minus by minus is a plus and plus by plus is a plus. Okay, so squaring something always makes it positive. And when it's positive x, I don't touch the inequality sign. Okay, so let's bring those two pieces of theory together, and says that if I use a common denominator over here of x minus 1 squared, then it will make it positive. Okay, so multiply both sides by the denominator squared, and therefore the number will end up being positive. Okay, so I'm doing it here to make the left-hand side an overall positive, and what I do to the left-hand side, I have to do to the right. Okay, this x minus 1 on the bottom cancels with one of those x minus 1s on the top, so that I end up with x minus 1 by x minus 5 being greater than minus 3 times x minus 1 squared. Okay, so let's multiply it out. X by x, x squared, x by minus 5, minus 5x, minus 1 by x, minus 1x, minus 1 by minus 5, plus 5. Because of BOMDAS, I have to do the square bit first. You don't multiply in the 3 first. If you look at BOMDAS, this order comes before multiply, okay? So I have to do my powers first. So he'll be x squared minus 2x plus 1 when you multiply him out. Okay, and then let's multiply in my 3. I'll have minus 3x squared plus 6x minus 3. Does that make sense? I hope it does. Okay, it's looking like a quadratic, isn't it? So let's bring everything over to the left so that I end up with x squared minus 5x, minus 6x plus 5. The minus 3x squared will become plus 3x squared. The plus 6 will become minus 6x, and the minus 3 will become plus 3 greater than 0. Okay, 0 because I have everything brought to the left. So let's tidy that up. I get 4x squared minus 12x plus 8 being greater than 0. Okay, I'm going to divide across by 4 because I can see they're all divisible by 4. I get x squared minus 3x plus 2 being greater than 0, and that allows me to factorize it easier. 2 1s are 2, and then the factors of plus 2 that gives me minus 3, the two of them has to be minus. So x is equal to 2, x is equal to 1 are my critical values. Okay, so if we use the graph method to see what's happening, well, my critical values are 1, 2, and 3. Okay, you can compare to any stage along here because these are all the same equation, just written in different formats. So the obvious place for me to do the graph is from the quadratic, okay, because I'm now comparing to 0. Where is the graph greater than 0? Okay, is this a smiley face or a sad face? Well, it's a smiley one because my x squared is positive. So between 1 and 2, more or less. Okay, so where is this graph greater than 0? So again, my 0 line is here. Down here is less than 0. Up here is greater than 0. Okay, our question is greater than 0, which is this proportion of the graph here. And remember, these go on forever, okay? So all of these x values, if I use them as solutions, I will get an answer to this sum that is greater than 0. So my solution, when x is less than 1 and when x is greater than 2. And I like writing it as 2 parts with the word and in between, because as far as I'm concerned, this graph is discontinuous. It's broken here. Okay, so to me, it makes sense that the graph is, the solution is in 2 parts. Okay, be careful when you get your critical values that you don't think you're done. These are just literally the values that's on the 0 line, and you have to decide then, is that function greater than 0 between those values or outside those values? And in this case, it was outside.
If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice? In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.